A bar graph is a type of graph that shows the number of items in a specific category, and it looks like this. Y'all seen that before. I don't know if y'all seen dot plots though. A dot plot is a graph that shows the frequency of a set of data with a number line. So they'll give you a number line, and they will show the data with those dots. Okay. Both types of these graphs can be used to make part to whole comparisons. So that means we're going to be making a ratio. We're going to be making a fraction. Example 1. Use the bar graph to compare the total number of people surveyed to the ones who chose Barry. So if it says compare, you're going to be making a ratio. You're going to be doing part to whole, but you're going to also be dividing it because you want one number. So the first step is we need to find the total amount of people surveyed. So you would figure out how many people answered each one and add them all up. Okay? So 24, 26, 12, 22, and 16. They've already done that for you. This one's worked out. Totals 100 people. So divide the total number of people, because it said to compare total to the ones that chose Barry. So that's what we're going to do. So the total number of people was 100. And then how many chose Barry?
16. You chose Barry?
So we would divide that. And
100 divided by 16?
Yep. So it means 6.25 times as many people were surveyed than chose Barry. So 6 times more people. On the next example, the dot plot shows the number of free throws made by the members of a basketball team during their last game. What fraction of the total number of players, fraction of the total number of players made 2 or less free throws. So how many total players are there? You got to count those dots. There's 10 total dots, so 10 total players. And the number of players that made 2 or less. So if it says 2 or less, we're going to include that number 2.
There's 5.
So there's 5 of those. So it told us to make a fraction. That's what we did. Part to whole, and we're going to reduce it down as far as we can go, down to 1/2. Okay, like I said, those are already worked out for you here, but just so you guys can understand it a little bit better.
The answer is just 1/2?
Mm-hmm. So half of the players made 2 or less free throws during their last game. Okay, down at the bottom, use the bar graph from example 1, so this guy up here with the ice cream, to compare the number of people who chose vanilla. So we're comparing vanilla to the number of people who chose strawberry.
24
okay.
And 12. So
Good. 24 people chose vanilla. 12 chose strawberry. Yep. You're dividing those.
2.
2.
Oh, it's 2. Oh.
So if it says compare, you're still going to make a ratio, but you're dividing whatever it tells you first goes on top, and whatever you're comparing it to goes on the bottom.
Strawberry, 2 vanilla, and then if it was...
okay.
So 2 times as many people chose vanilla.
Kind of like a ratio. No, really.
It is a ratio.
Oh, okay.
It kind of is. No, it
It kind of is. Because it is. Hold on, I'm trying to get to this. Okay. The dot plot. So the weekly fitness center visits. The dot plot shows the number of times per week that a group of students use the fitness center. How many more students use the center 3 or more times per week than students who use the center less than 2 times. So how many more tells us we're going to be subtracting. So if it says 3 or more, I'm going to include 3, and I'm going to count all of those dots. So 3 and over. So 3 or more times per week should be 11 dots. Comparing it, seeing how many more go than less than 2 times per week. So if it says less than 2, not 2 or less.
11 over 2.
Yeah, you're just using less than 2. So that's just 2 dots.
So the answer is 5.5.
The answer is 9.
11 minus 8. 9.
We wanted to know how many more, so we're subtracting. Okay, The bar graph shows the number of pets that students in Mr. Murphy's class own. 3 says what fraction, so our answer is going to be a fraction. What fraction of the total number of students, so total is going to be on the bottom, owns 1 pet? So how many total are there? Got 6 plus 10 plus 5 plus 2 plus 1.
Oh, I just did 5.
So the total is 24, all of those added up. Now, how many had just 1 pet?
10.
There you go, 10.
It's 24.
Okay, so 10 over 24, what fraction? Now we want to make it as simple as possible in its simplest form. So let's reduce it. 5 over 12. So we know we're going to divide. And if whatever it tells you first goes on top of your ratio. So compare the number of students who own no pets to the number of students that own 3 pets. Okay? So whatever it tells you first is going to go on top. So no pets was 6. 3 pets, 2.
So 3.
Yep. So in its simplest form, your dividing would be 3. So 3 times as many people have no pets as have 2 pets. No, 3 pets. Number 5, what fraction? Your answer is going to be a fraction of the total number of students. So total goes on the bottom. Of students owns more than 2 pets. So not 2 or more, just more than 2.
So it's right? 3.
3, yeah, 3 over 24, which is 1/8. Good. Okay, same thing here. Compare the total number of students, so total goes on top, that's what they gave us first, to the number of students owning 2 pets. So the total is 24. How many kids own 2 pets? 5. So 24 divided by 5. So 5 will go into 24 4 times. You got to add a decimal. Okay. Okay, dot plot shows the number of computers, both desktop and laptop, that families use. So I would see, first of all, the total we've got here. So add all your dots. 1, 2, 3, 4. How many total? 13. Okay, so number 7 says, what fraction of the families uses 1 computer? So out of the total, how many use 1 computer?
3.
Okay, 3 over 13. Can I reduce that?
No.
Nope.
How you know that? Because you can't divide 13 by anything? Or 3?
Number 8, what fraction of the families uses either 2 or 3 computers? So the same thing, you're going to put it over the total. If it says 2 or 3, you're combining those numbers.
6.
So how many use 2 computers or 3? 8. And we can't reduce that either, so I'm just going to circle it. Yeah, when your total is 13, that's kind of... compare the number of families. Compare, okay? So compare the number of families that use 2 computers to the number of families that own either 0 or 4. So how many families use 2 computers?
4.
4. How many families use either
1.
0 or 4?
Oh, 2.
So 2.
Number's 2.
Ah, my marker didn't work.
No.
So you're reducing it technically, or dividing it. 4 divided by 2.
Wait, what?
So twice as many families own 2 computers as own 0 or 4.
No. Stop it.
Same thing on number 10. Compare the total number of families So we're going to divide the total number of families by the number of families that use less than 2 computers. Less than 2. How many families use less than 2?
4, 5, no, 4.
4, you're good. So 13 divided by 4.
3 point something.
3.25. So 3.25 times as many people total as families that own less than 2 computers. Last one. What fraction of the families use at least 2 computers? So if it says what fraction, we've got to put it over the total. And at least, if it says at least 2 computers, am I going to include
Yes.
2? Yes. So at least, so 2 or more. How many is that? 9 altogether. Okay?